Hi Majenko. I've had a heavy parcel this morning, so let's see what this one's actually reporting. That's irritating. So this is reporting 26 volts across the pair. So pull the top panel off. There'll be a bit of background noise, but is that better for you, Majenko? Hi Crimson. Yeah, this is the pack out of my one of my 1500 UPSs, and the UPS has been going off since Friday night to tell me that the battery pack has failed. So rather than get another set of batteries like this and rebuilding it, I ordered a complete replacement pack from my battery supplier, because these batteries are not from my normal battery supplier. I got these from a local battery supplier. At the moment, there's a 1500 at my feet, two 1500s over there, and two 1400s, plus the 600 for the ONT. So I am not short on UPSing at the moment. I am short on working UPSing, which is a completely different issue. So let's whip the fuse out of this. Yeah, the pack failed. I bought replacement batteries and transferred the fuse and the I've forgotten what connector that is, but the feed over to rebuild the battery pack. So the fuse, the cabling, and the top plate are from our APC, and the actual batteries are not. So the first thing to do is make sure these don't wander off. Hi Terry. So, because there's nothing worse than taking the pack to pieces and then finding you can't find the fuse or the screws for the fuse. For those who haven't met this sort of UPS, it's 24 volt system, so it's two batteries in series. Its bigger brother takes 4. So let's get these undone. If these check out, I will find another use for the batteries. Would that be the sort... When you say the bigger brother, do you mean the rack mount units or the floor standing ones? because the bigger brother to this in the floor standing one is actually easy to get upstairs because it comes in two sections. You can take the main battery pack off the bottom and take the UPS up and the batteries separately. Once you get over 2200, they tend to do that with the batteries. Would help if I turned in multimeter. $13.10, yeah. These ones, you lever the front panel off because it's just friction fit. There's two screws, a metal plate folds down, and then the batteries pull forward. Hence the connector for the actual batteries. So that allows you to disconnect the batteries while you're pulling them in and out. Yeah, these seem fine. These are 20 amp hour units. That sounds like the one that takes the 7 amp hour batteries, because this thing is equivalent to 4 7 amp hours. In fact, it's higher than that. But they do produce them with the 4 pack and the 2 pack, depending on which battery type you want. Hold on a sec. No, I don't have one of the other packs up here. Oh no, the packs haven't changed in that sort of time. You know, it's lead acid technology. What are you going to do? I do have the fun of people telling me, for example, that I should replace the SC1500s on sites with the... I'm trying to remember the model. But with the lithium-ion version. And there's a couple of reasons why not to, and why to stick with lead acid. The first is, they're saying, well, you don't have to change the batteries in the lithium-ion one. And the answer is yes. But the unit, when you take the cost of the lead acid UPS and 3 sets of batteries over its life, it still doesn't cost the same as buying the lithium-ion UPS in the first place. There's about a £500-600 difference. The other one is space. The APC lead acid is a 2U unit, and the lithium ion is a 3U. It's shorter, but you can't directly replace them without rearranging the whole rack, because you need an extra U for the UPS. You know, it's a 50 centimetre deep 3U versus an 80 centimetre deep 2U. So, yeah, for the sort of use we have, you don't save any money, and you've got to rearrange everything to make space for the bugger. What happened there? Oh, sorry, Swarm. Where are you? How can I undo that? No, I didn't ask that. Where's that gone? Caught the trackpad wrongly. There we go, found it. Sorry about that, Swarm. No, it's the track. I use the trackpad on the Dell instead of a trackpad on the keyboard, and it's a lot more finicky. Yeah, these are the slightly later modelling. They're the black ones. But there's no real difference between them apart from the plastic of the casing. But yeah, it is possible to split that bottom section off in some models, and then the batteries can go up on their own. Right, so those seem okay. Let's get the next one. So this one is an MDS. This is 7 years old. This is a genuine APC for the same model. I don't know if we've got a construction time on this one, but let's see what we get on these. Yeah, that one's quite dead. 3.5 volts across the 24 volt system. That one's not so bad, 20. So the question is, are they both dead or is it just one? So we have to. There we go. There's the top plate. So 9 volts across that cell. Well, set of cells. 11.3. So I would make a rough guess that we've got one good and one dying. Let's see if this is a lot harder to get into. Because APC decided they'd go from a one piece to two bits. So this is 2.4 volts, 1.3 volts. I think this one is quite sufficiently stuffed. No, there's no balancing on these. When you get to the multiple packs, they treat each one as a separate system, but on these and on the rack mount, they're just done as a. Well, the rack mount one is done as a series with a parallel pair, but there's either 2 or 4 cables. There's no internal balancing. You've got to get to the big ones for that, mostly because of the problem of the connector. Normally they end up dying at the same time. It's one of those, there's only so much life you can get out of these. So recover the bits that make up the pack. That way I can get some more. Are they CR? I think the CSB battery units. This is where the fun comes of this battery supplier. they produce APC compatible batteries, but they actually use the same make of battery packs, which means the capacity tends to balance out better, unlike these ones. We'll see what these are when we get them apart. So again, keep the screws together. The thing is, Majenko, with these sort of lead acids, they don't tend to creep apart that far before they die of old age. And I will use the term old age loosely, because of course it depends on how bad your power is. We've got one site that's in an industrial estate, and it gets hit every Friday when all the other companies shut down around them. And we hit about 260 volts on the incoming feed, and then on Monday morning you come in, look at the logs, and the power's been down at like 180 when everyone's powering up. So we get about 2 years out of a set of batteries there, which isn't really enough time for them to fail individually. This is what I mean about why, for us, lead acid's a perfectly acceptable battery chemistry, because the power's so bad, the UPS is kicking in and out every day, well, every week. That's good. I can always use those to link stuff together. It's an industrial area, Swarm, so you've got big heavy induction equipment that suddenly shuts down, and of course the local area, the power jumps through the roof for 5-6 minutes. This is the technical bit, because they are literally stuck together with a pad in the middle. There we go. Yeah, CRBs. CSB, sorry. So these are... Where's the bit with the actual spec? Yeah, see, these are only 17s. Crimson, not at the moment. Basically, lithium ion gives you longer life of the UPS, both in runtime and how long the batteries last. But the extra cost doesn't rate any better. So you will pay more over the life of the UPS through buying the lithium ion version than you will from buying the lead acid version and changing the batteries a couple of times, because it's only £120 for a pack of batteries, and that's in a built state. Yeah, you can see the big pad here that's used to stick them together. So let's see about getting the APC one to pieces. So this is the genuine one, and you can see the only real difference, apart from an APC label, is you have an extra, as well as being stuck to the bit middle, you have an extra piece that always breaks, so which is why I never really care about it. Let's pull this off. So that's stuck to the bottom, and this is actually your handle to pull the batteries out, but by the time you need to use it, it always breaks at that point, and you tend to grab it, pull the batteries, the tab splits in half, and you've still got to try and leave other batteries out the hard way. On some of them, you can use they put a second pull lanyard on, so you can basically tug them out by the top, but half the time you just end up having to use a screwdriver to lever the batteries slightly so you can get your hand on them, because once you can get your fingers to here, you can pull them out by the grips in the batteries. To give you an idea of some of the ones I've worked on, we had I can't remember who it was. I think it was a Merlin on a site, which was in the configuration we were running it. This is out of a 1500 VA UPS. That was 40,000. Sorry, 40,000. And it was hardwired and 3-phase. So your battery pack in that, it took 12 volt, I think they were 10 amp hours, and it took 20 of them in the main unit, and then it had a second battery pack which was 7.2 amp hours, which connected to it to give extra batteries. And with the whole thing connected, with both packs in, it was 70,000 VA, and it wired directly into the building. You didn't bother with, IEC feeds. The feed input went in through 3 standard DIN rail breakers, so the sort of thing you'd expect to see in a distribution board. And the outputs went through similar systems, and the changeover switch was remote. So to put it into, say, bypass mode, you'd actually go to a cupboard in the admin office, open it, and the bypass system was on the wall inside the cupboard, and so you'd flick it to bypass, then you could go to the UPS and turn it off, and then you could get one of the Sparkies, and luckily it was an electrical installation firm, so I could just grab a Sparky, but I had to get them to disconnect it from the building wiring, both feed and output. So I have some pictures on my Flickr of that one, and one of the batteries had boiled to the point that the top of the, and like I said, we're talking the 7.2 amp hour cells, so they're only about that deep. The top of it was 5.5 centimeters above the top of the battery, with a hole in it where the acid had boiled out. And they were Panasonic batteries, and the writing on them was incorrect because the battery actually had writing on both sides. The writing that had been printed onto it as new, and the writing from the battery next to it, that it had heated up and transferred off that battery onto this battery, so of course it's a mirror image. And strangely enough, that UPS was in a failed state, so over its life we changed all the batteries and got it working again. And when I stopped doing the IT for them, it was still there under the stairs. But yeah, that one weighed, the main unit I think was 90 kilos. We tend to just move it with a sack barrow rather than dragging it across the floor. The fun one of that one was all the sockets on the trunking around the office walls was UPS. So you didn't have to have a UPS on the server. You just tagged into the building UPS. So again, we've got a pair of stickers. Oh, I just never get around to it. Crimson, I just lever them out with a screwdriver. Yeah, so again, these are 17 VAs, not the 20s. I mean, I could blame the make, because these are CSBs, which is Hitachi. I don't know if it says. I think these are these old enough? Yeah, these are old enough to be CSBs, whereas these ones, which are exactly the same battery, have Hitachi Chemical Energy Technology on them, Vietnam, which is they're made in exactly the same factory. It's just Hitachi bought them. So I might have to get a sealed lead acid charger and look on these, but this one I'd say is the failed one, because this battery is flat, mostly flat. This one is not, and it won't show this on camera unless I get the angle right, but there is a line here and here and here and here, and this is where the cells are, and it's the same on the back. And again, I don't know if this will show up, but you can sort of make out the ridges where the cells have expanded. So that cell has gassed, in fact, and that one the worst, because they've stressed the plastic, but all 6 have gassed off. So that one is stuffed. You know, that's completely stuffed. This might be completely stuffed. I bet you this is the one that's at 2 volts. No, that's stuffed. But not as stuffed as that one. That's better. So that's got 1.2 volts. And that is reading 2.4. So the one that's bubbled is actually showing more residual charge in the cells. Officially it's a normal 12 volt, but you charge them at about 14. So if you take this one, which I now think is a good cell, so this is a 12 volt 20 amp hour instead of a 12 volt 17, and if we do the same on this, this is currently reading 1318. So you basically treat them like a car battery. So nominal 12 volts, charging at 13 to 14. If they drop below 10, they're probably stuffed. Hi Matt. They've just got the advantage, unlike cars, that their drain isn't so high. But, like a car, they're continually cycling between charge and discharge, because every time the power goes off, you're in discharge, and it doesn't matter how little is used out the battery, the moment the power comes back, they charge up to full capacity again. So if you get a brief blip, you'll switch onto battery, off again, and immediately start charging. And it's those little short blips that's actually worse for these than a decent run and letting them charge down and then charge slowly back up again. So you're always cycling between on and off and on and off. It's a bit like, well, the best example to give you from computers, it's a bit like a Dell versus a Lenovo. If you take this machine that I do the streaming from, which is a Vostro series, if you disconnect the power and plug it back in, the battery will power the laptop and then it'll immediately start charging. If you take my X270 and you unplug it and plug it back in, it will change to one of the batteries, start to discharge, and when you plug back in, it will change back to mains input. it will not start charging the battery. You have to drop the battery below 80% before it'll actually start recharging it, to just stop it being continually slight cycling of off on, off on, off on. If you take the X270, to give you an idea, to show you how complicated the battery management actually is, it has two batteries, internal and external. When you turn it on, it will use the external. It will run down till it's flat, and then it will swap over to the internal. If you then disconnect the external and plug another one on, it will disconnect the internal and go back to the external, run that flat, and then go back to the internal and discharge that. When you then plug it in, it will then start charging the internal battery to 80%, then it will charge the external to 80%, then the internal to 100, and the external to 100. And the idea is to always have power, wherever possible, in the internal battery. So that's the one that charges first and discharges last. But it charges it in that way to get the best battery life out of them. These don't. This is literally, if it's going on, off, on, off, on, off, on, off, you will do interesting things to the chemical makeup. Basically, you will cause holes in the lead paste, and there's nothing much you can really do about it, apart from run it decently down and let it recharge slowly and let everything migrate back into place. That, you know, once you get past a certain point, you're stuffed. But if you've got slight degradation, yeah, you can just let it discharge and recharge. But you're not going to turn around and do that to a server rack, because what happens if you have a power cut just after you've done your test? As Majenko says, you always want it to be charged. So whatever happens, if it's dropped below 100%, it's recharging when you put the power back on. It's good that these don't actually have any contamination. Quite often you open these up, and especially for smaller cells, which use, instead of the bolt-on connections, they use spade connections, you will find corrosion around the terminals, often to the point it's eaten the connector. I have replacement connectors for APC UPS cabling for replacing those cables for when they have basically eaten themselves, because of course there's nothing like a bit of sulfuric acid. So right, I'm going to move these off and see if I can pull one of the other UPSs up. So hold on. Oh, tell me about it, Matt. I've got 80 plus kilos of them. Hi, Jupin. Right, so they're all the bits to rebuild a UPS, or 3. I wonder if I've got something I can stick them in so they don't go missing. I will find a box for those later. Well, to be fair, when I have stuff like that in the car, I try and avoid taking them out because they're heavy. I have a newer Smart Ups down here, and I'm trying to work out if I want to put in the effort to check it out. You can tell it's newer because it's got a front panel display instead of LEDs. Yeah, I just dropped mine off for recycling. It's, from my point of view, it's not worth the issue of trying to get some money back on them because the amount of paperwork's just too much for me to bother with. I want them gone. Right, so this is the big one. This is a FJT 1500i. So this one actually has a this one's actually a fun one. This is a genuine APC Smart Ups badged Fujitsu. So if I turn this around, there you go. It's Fujitsu Smart Ups 1500. It is definitely an APC. Put this one will do. So this is a twin bank 8 output. Claims 73%. Let's go to one. And when you actually hit the front panel, it tells you APC by Schneider Electronics. I'm trying to think when this was built. So this is doing a self-test. And in the self-test it went nuts. So let's Is it going to do another self-test? Hopefully this should be shutting down. There we go. So let's yank the front panel. This is one where they fitted a longer cable and then cable tied it to make it shorter. She's like, yeah, thanks. So I think this will take a RBC7, which is the same as the ones I've just dismantled. Let's see here. Missing front panel screw. So yeah, there's the panel coming out, and this one, it hasn't broken yet. So let's have a look. These don't feel bad. So much easier to move that. Doesn't have that in. Because if the pack's okay, I'll use this pack in a another UPS while I try and work out what's up with this. Yeah, see, 25 volts should be okay. So I suspect that it might be the circuitry in this one that's playing up, but I do have a spare that I can put that pack in. Unfortunately, it's behind the running, well, under the running one, so it needs two people to get it, because I need to pick up the UPS that's running and get the other one slide out from underneath. And think this says something about my battery supplier and APC. How much thicker the cabling they actually used on the battery packs are. I don't want to lift this down, even though it's lighter now. But I better do it so I've got some space. Hang on. It's very much the Spaceballs hairdryer. Yeah, I could, once you take it out of the box, I could carry 2 or 3 of these things. Right. Hi Daft Punko, if I haven't said hello to you. And Carl. And Disconnected Dan and Dopez. I can actually see everyone. Right. This is the problem of when you don't have something to stick the parts in immediately. And I don't particularly want to put them in with the batteries. But I suppose being APC parts, technically they are to do with batteries, so at least they won't go missing. So if I power up that one. Get all the stuff off the desk now. There we go. Let's see if I can not murder most of my team this time. Okay, sound didn't like that. Okay, now I've got no sound at all. Yay for cheap drinks. Aha, found the fault. When I slid the volume slider up on OBS, it muted the input from the Extron. That would do it. I did say they were untested. It always gets me in this that the mouse cursor points the wrong way. Fudge. I can't cope with high temperatures, even with AC, because AC dries me out, and I end up coughing up blood, which is not a good outcome. Well, I guess I'm going to be ordering some new batteries, and probably testing this unit in a in the other APC when I can get it out. I'm trying to think if I've got a different pack I could swap in, but I don't trust any others. Yeah, but I've also got power bills, Matt. I mean, to give you an idea, my power has recently gone down to only 19p a unit. So the AC that's on the wall behind me for the computer room can happily eat its way through £1 an hour. Because it isn't a small unit. I mean, this room is what? 2.5 by 4 meters, and that's a 24,000 BTU medical grade aircon. So it doesn't need to run a defrost cycle on its own. It can defrost while running. That's the normal term of the medical grade stuff, is the fact that you can set it running and it will run continuously, doing its own maintenance while still running. And yeah, you can tell when I turn it on because my power graphs get a jump in them that looks like Everest, because the computer room uses 0.5 kilowatts on its own, so it's a 10-fold increase to run the aircon. And it's nice until you look at the bill. So, let me switch that back to. Come on. Switch for the Extron, which is up there. This is why the aircon here only tends to run in the height of summer if I need it. And if I need it, the sun's probably putting 3.8 kilowatts onto the roof, which offsets so much of the cost. I have a 17 panel, 300 watt per panel PV array across 5 different sections of roof. Yeah, it's I don't know if I have a picture of it accessible. The PV array here went live in March 2020. and 19. The system I'm on closed to new applications on the 1st of April 2019. I am on what's called an assumed tariff, so I get paid a small amount for every kilowatt hour I generate, and then 50% of that you are paid a higher rate because it is assumed that 50% of what you're generating goes back into the grid. So the cost of every kilowatt hour I generate, I think, is 4.3 pence, and then 50% of that is 6.9. So for half of what I generate, you basically make 10p, and if you have to buy it in from the grid, it's 19 point something at the moment, 19.87 I think at the moment. So all the savings on my system are not from what you're paid, but that's nice. It's how much you don't have to pay out, and for that I'm double dipping. Because you might wonder how you can double dip on an assumed system, and the simple fact is my company has to pay me for the power the computer room uses, regardless of where it comes from. So every 2 hours in summer in daylight, the computer room uses 1 unit. The company therefore has to pay me 19 point whatever p, but if it's come off the roof, I don't have to pay anyone else, and that UPS is still triggering with a new battery in it. Why hasn't it done its test properly? Anyway, but so all my actual payment for the unit is in what I haven't paid and the company has had to pay me back, versus what I'm actually paid for having the system. The earlier you got into the scheme, the more money you got. My mum's system is from 2011. Oh, by the way, this system runs for 25 years before the funding changes. So my mum's system is 8 years older than mine, and because the system's more expensive because she was, quote, an early adopter, although her system is smaller than mine, she gets paid 36 pence per kilowatt hour instead of 4. Simply because she got in there a lot earlier than I did. However, and this is where it gets really stupid, when my mum's system was fitted, they screwed up. If you were to look at my income downstairs, I have a unidirectional digital watt-hour meter. So basically it's a small box, incoming feed, outgoing feed, and it counts every kilowatt hour that moves from the left to the right. When Mum's system was fitted, they didn't change her meter. She had a moving coil meter. So every time she generated more power than the house uses, the meter turned backwards. And they didn't spot this until her outgoing went under her incoming. So she suddenly gave a meter reading that was now lower than the last one. This took a few years. What makes it even more funny is my mum is an ex-sports teacher. So in 2012, she volunteered for the London Olympic Games. And my brother had a flat in London because he's an army officer and he was working in Whitehall. So he had a flat in the city. So rather than get a hotel, Mum just pinched his flat. So she didn't have any real costs. You know, she had food and things, but she didn't have any accommodation costs for 6 weeks. So there's no one in the house. It was quite sunny for the Olympics, and her meter spun backwards. I would often turn up when passing to recharge my laptop because it's going to be free. So she comes back, and the next year this meter reading goes in. So they send out an engineer to see what's happening with the meter reading, because obviously it's wrong. He takes a look at it and realises there's not a single fault with the meter, but because the meter wasn't replaced, it's the wrong kind of meter. So he's going to change the meter, and he takes one look at the board that the meter's mounted on and goes, I think that's asbestos. I can't touch that. And the thing you have to take into account is the way the electric system is set up in the UK is very unique. The board, the incoming feed, and the main incoming fuse are owned by the electricity network. The meter is owned by your electricity provider, the company you actually pay, and everything beyond that is your problem. So the distribution board, everything like that is yours. The meter is your distribution company, and it's your supply company, and the incoming feed and the board it's on is the distribution company. So the guy dealing with the meter can't touch the board because it technically belongs to the next company. So they put in a request with the local grid to have it upgraded so they can change the meter. To do this, the grid turned up and dug up Mum's drive, put a complete new feed into the house, and a new incoming fuse on a new board. At which point, the meter guy could come back out, put the new meter on the new board, and connect the house up, and be done. This took another 6 months. In the summer. Well, the meter is still spinning backwards quite a lot of the time. Because as you can imagine, when Mum's not in, there's the fridge, the freezer, and a few things on standby, and the VDSL modem, and the router. And that's pretty much it. So the electricity supply company was now in the position that they knew how much Mum had generated and how much they owed her, but they had no idea how much she pulled from the grid, because they had no idea how much of what she generated had been offset by the meter spinning backwards. So they couldn't charge her, but they still had to pay her. Her system was paid off quite early. But those are the sort of screw-ups that happened. But if you remember the old joke of, if you're playing Monopoly, bank error in your favour in the community chest, this really is a error in your favour. It's normally estimated that your system would pay itself off in about 8 years. Mum's did it in 4.5. And she still got, well, at that point, she still had 21 years of her fit contract left, because it's a 25-year contract. So her system will go to standard billing sometime in the 2030s. Mine will go to standard billing sometime in the 2040s, because they were trying to get people to adopt it, and they gave you this big long contract. But yeah, the idea of sitting, I actually did that. When Mum was down in London, I was at her house, and I sat in the garage watching the meter spin backwards, going, "There's something wrong here, but it's not my problem." But yeah, the modern systems, after the fit system closed for mine, the new system is done on a much simpler basis, that you have to have a smart meter, and it will therefore count what goes left and what goes right, because the meter is wired feed on the left, internal wiring on the right. So it will tell you how much has gone in and how much has gone out. And to give you an idea, if you're on a fixed tariff at the moment with my provider on that system, you will pay 21p a unit for incoming, and you will be paid 10p for outgoing. So if you send 10 kilowatts, you get basically £1 back, but you never get as much as it will cost you to pull in from the grid. There's two reasons I've done this. The first is to make things easier, because it is easier to monitor it in both directions now. But the other reason is, of course, the development of battery packs, where you might generate it and not feed it to the grid and just store it. At which point, the only way to know what you have fed to the grid is to have a meter that can record this went in, this went out. Stupidly, although my main meter can only tell you what's come in, my generation meter is a two-way meter. So I can tell you that I have generated X megawatts since it was set up, and the inverter has pulled 0.1 kilowatt hours in the 7 years since the system went live, and that's the power it needs to run when the array isn't generating, so that all the settings are running, etc. So it's used 100 watts over 7 years to sit in standby. But that's all that meter can tell you, because that's the only power that goes in the other direction through that meter. It makes it a bit of a pain when you want to do a meter reading, because it switches between the incoming and the outgoing. And so for many years, the incoming was 0000.0, and now it's 0000.1. So, but it was a very strange system, but it's nice to watch it. It's nice to watch the power coming in. But it's also why I've refused one of the reasons I've refused the smart meter, because the sort of engineers I send out to fit them are not qualified to work on a system this complicated. I need an industrial electrician, because up in this corner that you can't see is the generator changeover switch, because I can run part of the house off a generator feed as well. So pulling the main incoming fuse does not guarantee that the system is safe. If it just had the PV system, it should shut down the moment it loses contact with the grid, because it's designed to be grid safe. If you do not have a grid feed to harmonise with, turn off. But the generator's a completely different issue. So anyone who works on this system needs to understand domestic wiring and industrial multi-point incoming feeds, so that you know I have turned that isolator off, I have checked that isolator, and I have pulled the fuse, and now it is safe. But like I said, domestic don't understand that. I understand the kill switch for the PV array, because this system has 3 isolators. There's one down on the disk board, there's one in front of the inverter, so literally the wiring from the disk board goes through the breaker to the master cutoff, upstairs to a second master cutoff, and then into the inverter, so that you have one at each end. The overrides, yes, they are rotary switches with locks for padlocks. But there is then a second isolator, again, that can be locked out on the DC side, which is the incoming from the array itself. So you can cut the inverter off from the DC and the AC in one place, and the AC can be cut off in 2 places, and you can throw the breaker as well, so technically 3 places. But people don't understand that. You know, it's designed to be as safe as possible, but you need people who understand how it's safe, so that they operate it correctly and it will then keep them safe. But yes, if you've ever seen the big rotary switches that have a collar around them, and then there's a hole that lines up so you can put a padlock through it, that's the basic design of my isolators on all three of them. You can throw them into off, and once they're in off, you can put a lock through them to mechanically isolate the switch, and at that point you cannot rotate it because you've got a 5mm steel shackle through it. So the AC is the same. The AC power actually comes in up here, but then it feeds the compressor outside, and so there is a isolator outside, so that if you're working on it, you can isolate it in front of your eyes. Because that's the last thing you want. This is a wired-in system, and you don't want a 5 kilowatt feed without an isolator. I mean, 5 kilowatts is going to be what so it's going to be somewhere around a 20 amp feed. To give you an idea, the shower's 36. Sorry, no, yeah. Yeah, the shower's a 36 amp feed, and it's a 7.6 kilowatt unit because I overspec the cabling, as I do. I think I could probably put a 12. Let's ask it. Let's do the obvious. Yeah, the actual feed is wired to around 50 amps. But it's currently covering a 31, 32 amp feed because I overspec'd it, just in case I wanted a more powerful shower. But that is quite a thick cable, therefore, running around the side of the house. But it's why I sort of laugh when you get people going, if you have a really long shower, you run out of hot water. Nope. No, I've all the houses I have lived in have either had no shower or an electric shower. Therefore, you either had a bath, and therefore the amount of hot water didn't matter once you filled the bath, or it was an electric shower and you've got unlimited hot water. So the biggest problem would be if someone turned the sink on in the kitchen, which would drop the water pressure, and then the shower might turn the heater off, at which point you are perfectly allowed to scream and jump out of the shower. Because there is a pressure sensor in the shower. If anyone's watched Big Clive's videos on the different electric showers he's taken apart, this is the more modern of the ones he took apart. I think it was actually a Triton, just different model to this. So you have a restrictor which sets the temperature and a pressure sensor, pressure switch. So if the pressure drops, it will cut out the heating element, at which point you get very cold water very quickly. And like I said, it is perfectly acceptable to scream and jump out of the shower at that point. If you want weird bypasses, Daft Punkle, there was a chip shop I've done work for where they bypassed the gas meter. And they had someone come in to do some work, isolated the meter, didn't notice that it had been bypassed, went to do some work, and had a 3-meter flame shooting out the wall. Because even with the main isolator valve off, the gas was still flowing. The advantage is that mains gas is not massively pressured. It's under pressure, but not a huge amount of pressure, so the amount that comes out for a certain size hole can be quite limited. But yeah, they had a flame going straight down the chip shop. So that was. I think he's finally paid his bill as well. So, but yeah, these are the sort of things you come across. There was a supermarket in the UK. The name has been reused. It's been bought, but it was Wilko's, and the Wilko's in my town, when it's shut down, it was in a pedestrianised area with a second floor, and after about 8 months after it was shut down, they got to raid it because a cannabis factory had been set up on that first floor. And of course it's a big open warehouse space, so huge amounts of plants and a bypassed electricity meter to provide the power. Oh, it only gets fun if you're melting bits of cars if you do it with a building. I'm not thinking of a walkie-talkie in London or anything. For those who don't know, there is a building. It's not on St Mary's Axe. It's the next one over. But the architect made it a concave curve, and it looks like an old Motorola two-way radio. But it in certain conditions, before they put blinds on it, and the blinds are on the outside, it could concentrate the sun, and it would concentrate them across a bit of on-road parking, and it would melt bits of the plastic on the cars. The bit most people don't know is that was his second building that did it. He built one in Las Vegas that did exactly the same thing. So it's not that he made a mistake, he made it twice. And it's one of those, when you do it the second time, it's a bit hard to say it's a mistake. It starts to feel a little bit more deliberate. I should go and have a fight with a machine next. I have hit a problem with one of my little machines that I let the operating system... Well, let me rephrase that. I upgraded the operating system on it, and XVNCD appears to have disappeared, which is a bit of a problem, because now I can't remote desktop into it to get to my mail client in X. And I haven't figured out a solution to this. XRDP is working, you can connect to it, you get a session login, but none of the options you can select for the actual X server will let you connect, will actually run through, connect, and get you to the desktop. So I need to fix that. And I've been putting it off because I don't know what's wrong with it yet. So... One of the other things I'll have to do is to let this machine upgrade, because this one hasn't actually upgraded for a little while. Oh, that's a fun one. I'm sort of used to worries like that because we have 2 oil refineries. It's 12 miles from here, so let's call it 19 k's. But at one point they were storing natural gas by pumping it into the underground aquifers, and the joke was that if you dropped a match in the wrong place, you could probably take out most of the county. And you definitely know about it because it's the sort of boom that you would get reports on seismographs from other countries. Because let's face it, if you're going to... As one of the comments goes, if you're going to screw up in such a way that people ask, how? It's like the one of the American truck that's hung upside down on a guide wire for either an electric or telecoms pole. And you can just look at it and go, how did you do that? That's the sort of screw up you need to do. You know, a screw up where people ask how you did it. Right, well, I think we'll call that for today. So thank you everyone for turning up. And I'm now going to peer at some batteries and probably swear at them.